Okay, determine the two figures are similar using angle, angle, side, 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 and side, angle, side similarity. By verifying that angle measure is preserved and corresponding sides are proportional and used to make conclusions. Alright, so this right here will help you out. Remember what the three things are, right? These are the only things we can use. Angle, angle, side, 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 and side, angle, side. So looking at our first problem, what do I have? Well, I have three sides. So I'm probably going to be looking at side, side, side. Remember, we are doing small over small, middle over middle, and big over big. So, my smallest number here is 12. My smallest number here is 27. Middle over middle. My middle number then over here is 16. My middle number here is 36. Then big over big. Biggest number is 20 over 45. Again, one thing to remember is all three of these numbers should come from the same triangle, 12, 16, 20. Good. And all three of these numbers should come from the same triangle, which again, they do, 27, 36, 45. If not, you have to flip them so that they do, okay? So be careful with making sure I had the right triangle on top, so the right triangle is always on top. Okay. Then I'm going to see if my fractions reduce. 12 over 27 does. It reduces to 4/9. 16 over 36 also reduces to 4/9. 20 over 45 also reduces to 4/9. So yes, these are similar by side, side, side. And these two triangles are similar by side, side, side. All right, number 7, determine if the triangles are similar. If they are not similar, select not possible. Well, the first thing I see is angle, so I'm going to try to do more with angles and try angle, angle. These have the same mark. I'm going to go with this one is 91 degrees as well. Then I'm going to use my triangle angle sum theorem to solve for one of my missing angles. It doesn't matter which one you solve for, but you do have to solve for one of them. So I have 23 plus 91 plus x equals 180. I'm going to add 23 and 91, and I get 114 plus x. And then I'm going to subtract 114. So x equals 180 minus 114 is 66 degrees. Okay, so that C is 66 degrees, and that looks great because then I can say angle B is congruent to angle E, and angle C is congruent to angle F, right? 66 and 66. So there are my two angles. So again, yes, these are similar by angle, angle. All right, looking at number 8. Determine if the triangles are similar and decide how. Well, right now I see that I have two sides in an angle, so I'm going to try and go with side, angle, side. Okay? So with side, angle, side, I need to start with small over small and equals big over big. So, my smallest side in this one is 4 over 2 is my smaller side here. My biggest side here is 6. Here is 3. So 4 divided by 2 is 2. 6 divided by 3 is 2. Great. My sides work out. The next thing I need to see is, does the angle between them, between those sides, are congruent? So, I draw the lines I just used, so 2 and 3, and then 4, where 4 is and where 6 is. Those are those sides. The angles between them are angle A and angle P. So, can I say angle A congruent to angle P? No, there's nothing there. I can say angle B and angle Q are congruent, but that's not the side, or sorry, that's not the angle between them. Angle A and angle P they might be congruent, but I don't know. I can't say they are congruent. Okay? So, these I would just say are not similar. And the other way to think about it is start with your angle, or start with like anything and see what you have. I have angle, then my side, then my side. Angle, side, side. That's not one of our similarity theorems. Okay, so be careful when that angle is outside the two sides. Remember, it has to be side, angle, side between the two. Alright, let's look at number 9. In the diagram below, are the two triangles similar? How do you know? Justify your reasoning. Okay, so for this one, more than any of the others, we have to show why we know they're similar. Well, if I look here, I know angle, I'm going to draw on the lines WTU is congruent to, right, draw the two lines that connect this, VXU, okay, by, right, it's given to me. They're both 55 degrees. The next thing I can say is angle TUW is congruent to angle VUX by, remember, those are vertical angles. Anytime you have that bow tie shape, okay? All right, the two lines crossing, they are vertical angles. Okay. Then the last thing, right, my angle, and then my triangle. Triangle, I'm just going to say TUW is similar to, well, T goes with X. And then I use U, so I'll use U and V, right? X, U, V. Make sure we're matching up our sides. By, what I used? Well, I had two angles. Okay, so by, angle, angle. All right, looking at, I don't know what's going on there. Looking at our last question for target B, it is our proof. So lots of things to fill in. Given LI is parallel to KJ, again, remember these two lines here mean parallel. LI is parallel to KJ. I want to prove triangle HLI is similar to triangle HKJ. Okay. So our first statement that's made in our proof is LI is similar to KJ. Well, I can say the reason behind that is it is given. Right? That was our first given statement. 2. Well, again, remember, anytime you have parallel lines, you have those angles that are congruent. That's one of the first things we looked at in B1. Okay, so I just need to figure out what angle I want to write. Well, if I look, number 3 is already one of the statements given to me, that HIL, this angle, and HJK, this angle, are congruent. So I'm going to kind of skip down to that first. And I know, again, when I have parallel lines, I have corresponding angles.
So skipping back up to number 2, I know that my other set of angles that I need to say are on the left side. HLI is congruent to HKJ. And those are also corresponding angles. We always have 2 sets of corresponding angles. And finally, number 4, the triangles are similar. Triangle HLI and HKJ are similar. Why? Well, I had angles here, so that's going to be angle, angle. Okay. That's it for target B. Go ahead, look that over, and move on to target C. All right, looking at target C, apply theorems, postulates, or definitions to find missing values. So the first thing I'm going to do is find the value of y in the given diagram. Remember, I always like to start with the variable, so I'm going to start with y. And this is our one of our side splitter theorems, really, because all these angles are congruent. So y over 11, right, they're both on the left side, equals, on the other side, right, I did y first, so I have to do the number on the bottom first, 14 over 16. And once you set up your proportion, you're just multiplying. I have 16y, or 16 times y, equals 11 times 14. So 16y equals 11 times 14, 0.14, times 14 is 154. Ooh, can't write today. 154. And I'm going to divide both sides by 16. Right. So y equals 154 divided by 16 is 9.625. Icky number, but that's okay. Or again, you could have it as a fraction. Either one. As a fraction, I believe that's 77/8. So either of those are fine. All right, looking at number 12, find the value of x in the given diagram. So again, I'm going to start with x. X over 17, right? They're on the same side. Then, on the other side, again, x is between this line and here, h and y. So, I gotta look between, right, this whole thing, where it goes with x. So I have to add those together. 16 plus 22 is going to give me 38. Okay, so always be looking for, is it just a piece of it, or is it the whole thing? So this equals 38 over, and then 17 was this piece. So on the other side, that's going to be 16. Again, once I have that set up, I have to do my cross multiplication. I have 16x equals 17 times 38. Before I do that, 16x equals 17 times 38 equals 646. Divide both sides by 16. Wow. Sorry, should type it in the calculator. 646 divided by 16 is 40.3. 40.375. Or if you got it as a fraction, 323 eighths. Either one. Okay. Alright, looking at number 13. I believe yours already has this typo fixed, but mine does not. So this triangle is named wrong. It should be triangle UST, not triangle SUT. Okay, that was just a typo, and like I said, I believe yours is already fixed. Okay, so looking at this, again, I'm going to start with my variable, 5x plus 11, over. Now, looking at UV, I then need to look at US in my other triangle, which is here. That's over 18. Okay. So again, since 5x plus 11 is from this triangle, it is on top, 88 from the same triangle needs to be on top. Okay, and that's BW. And that should then match with ST. So that should match with 24. Okay. Then again, I'm doing the cross product property, but be careful. I need my parentheses. Okay, remember, anytime you have a plus sign or a minus sign, you need those parentheses. So I have 5x plus 11 times 24 equals 18 times 88. So I'm going to cross multiply, or I'm sorry, not cross multiply, just did that. I'm going to distribute 24 times 5 is 120x plus 24 times 11 is 264. Equals 18 times 88 is 1,584. So I'm going to subtract 264 from both sides, and I get 120x equals, well, 1584 minus 264 is 1,320. And then I'm going to divide by 120. I get x equals 1,320 divided by 120 is 11. So x equals 11. All right, looking at number 14, Cassie claims that triangle ABC is similar to triangle DFE due to the fact that the sides are not congruent. Is Cassie correct? How do you know? Okay. So, first thing I have issue with in Cassie's claim is for triangles to be similar, right, which is what she's saying, sides do not have to be congruent. Angles have to be congruent, not sides. Okay, and that's what I have here. And sides have to be proportional. Okay, sides do not have to be the same for triangles to be similar. Okay, so I have my sides. Right? So I'm going to do the small over the small. That's 8 over 12. And I'm going to do the larger over the larger. So 8 over 12 reduces to 2 out of 3. 16 over 24 reduces to 2 out of 3. That looks good. And the angles between them, right, well, if I connect those two sides, have to be congruent. Well, angle B
is congruent to angle F. Okay. So, Cassie is incorrect. The triangles are similar. By side, angle, side. All right, then our last question. Taylor observed that a truck was casting a 7-foot shadow. A nearby 25-foot high billboard was casting a 30-foot shadow. Draw a diagram. So we have our truck that's casting a 7-foot shadow. I don't know how tall the truck is, right? Never tells me. And then we have a 25-foot high billboard casting a 30-foot shadow. 25 feet. There's my diagram. That's all you have to do. Then, set up a proportion that models the situation, determine the height of the truck. So I'm just going to do x over 7 equals 25 over 30. Cross multiplying 30 times x equals 25 times 7. 30x equals 170. Oop, I don't know where I got it to from. 175. Erase all that nonsense. 175. And then my last step is to divide everything by 30. Right? So I'm left with 1x equals 175 divided by 30 is 5.83 feet. Or, if you like fractions better, it's 35/6 feet. Either one, depending on whichever one your calculator gives you. I am not picky personally. That's it for target D. Go ahead and look at, that's it for target C. Look over that and then look at target D.